Hello everyone, welcome to this video. In this video, we are going to talk about CI/CD. What is CI/CD, what is GitLab CI/CD, and anything about it. So make sure to like the video, subscribe to the channel, and don't waste any time. So let's start from how we used to deploy software. Not that long ago, about 10 or 15 years ago, back then deploying an application usually means logging into server manually. Someone, usually a developer or sysadmin, would SSH into the production, pull the code, install dependencies, restart services, and hope nothing break. There was no automation, no safety nets, nothing at all. If the development failed, everyone panicked. If someone broke in production, we asked who deployed last, what changed, and very often no one really know. So, development were a scary event. Team delayed them, they did them at night, or they prayed before any problem happened, and that pain is exactly where CI/CD comes from. So, what is CI/CD? CI/CD is often explained by some promise. The promise is that every change to the code should be safe, tested, repeatable, and predictable. It means continuous integration and continuous deployment or continuous delivery. This is two factors of CI/CD. So, continuous integration means that developers don't work in isolation for weeks. They push code frequently, and every time they push code, something automatically happens. Or indeed, it means frequency push code to a shared repository and code automatically build, test, and check for error. No manual things, nothing at all. And we have continuous delivery or continuous deployment. There's a small changes between these two. Continuous delivery, as you can see here, means code is always ready for the deployment to any environment, staging production at any time. But continuous deployment means the code that passed all automated tests is automatically deployed to the production. So it contain building, package it, and deploy it, and anything. So CI/CD turns deployment from a scary event into a boring routine process. And in engineering, boring is always good. Let's go to next slide. Now let's talk about GitLab. What is GitLab? Many people think GitLab is just a place to store code, but GitLab is actually a full DevOps platform. It stores your code, yes, but more importantly, it knows what to do when the code changes. When you push code to GitLab, GitLab can automatically run tests, build your application, create containers, deploy it to the server or Kubernetes. All of these is described in a single file. It's called gitlab-ci, and that's very good. You can do it very easily. So that file is basically your automation brain. Okay, let's, before anything, talk about container and container registry. What is container? Before container, applications were tightly coupled to servers, and you should install all dependencies with fixed version. You install directly on the machine. Different servers had different configuration and environment drifted over time. Containers changes completely. A container is a self-contained unit. It includes the application and everything it needs to run. That means if it runs on my laptop, it will run on your server, it will run on the cloud, it will run in Kubernetes, and this consistency is why container become the foundation of modern CI/CD. The most popular container technology now is Docker. So we need to talk about Docker registry. As you can see here, Docker registry, or more general container registry. Once we build a container image, we need a place to store it, like GitLab, like GitHub, that you store your code. That place is called a container registry. Think of it like this. Git stores source code. A container registry is store build application. In a CI/CD pipeline, the flow is usually we build the Docker image we have here. We build the Docker image, we tag it with a version, we push it to the registry, and later production pulls it and exact same image. This guarantees that what we test is exactly what we deploy. GitLab includes its own container registry which fit perfectly into CI/CD pipeline. We can use GitLab registry, we can use Docker registry, we can use some open source registry like Nexus or anything else, but you have very option. And let's jump about the CI/CD flows. The heart of CI/CD is test, build, deploy. Three main stages of CI/CD. Almost every CI/CD system follows the same logic. First, test. We want to fail fast. If the code is broken, we stop immediately. So then we build. We compile the application or build a container image. Finally, deploy. We release the application to an environment, staging production, any place we want. The key idea is that humans don't perform this step anymore. The system does. And we just check the flow is running or not, or if any problem there, it's safe because production not changed yet. So if I want to talk about these steps, we have tests, which we usually have unit test, integration test, end-to-end test, code quality, and something for testing your code behavior. And if a test fails, the pipeline stop immediately and prevents any production deploy. Build and try to build your images, build your anything you have, tag the image and push it to the registry. And next we pull it from a registry. You can use Kubernetes, you can use anything else to pull it and run it on the server, and you deploy it very easily without any human activities. So let's talk about GitLab components. We have stages, we have jobs, we have pipeline, and some more things. So in GitLab, everything starts with the pipeline. And a pipeline represented a full CI/CD process containing several stages, parallel jobs, and anything. Usually, pipeline trigger with code push, merge request, and manual trigger. For example, when you change your code, push it to the repository, and that code push can trigger the pipeline. Or if you create a merge request, it can trigger the pipeline. We have stages. What is stages? Stages are represented phase like testing, building, or deploying. They run in order. Stages are sequential. And as you can see, there is rules here. A stage will only begin its execution if all jobs in the immediately preceding stage have successfully completed, and more. We have jobs. What is jobs? In a simple word, a job is a single unit of work. Run a test, build an image, push an image, run a quality test. Anything is the smallest unit of things. So we have pipeline, that have several stages, and each stages have several jobs. Okay, let's talk about runners. What is runners? GitLab itself doesn't run your code. It's an important point that the actual execution is done by something called a runner. A runner is just a worker. It can be a virtual machine, a Docker container, or a Kubernetes pod. When a job is created, a runner pick it up and executed the command and report back. If CI/CD is the brain, runner is the muscles. Consume it like this. Runner environment is a place that can run jobs in different environments. Some run directly on the host, some run inside the Docker container, some run inside the Kubernetes. So you have Docker as the environment runner, Kubernetes, and some shell runner, and anything you want. The most common setup used is Docker execution for isolation or Kubernetes execute for scalability. So this flexibility is why GitLab works well in both small teams and large organizations. So today, Kubernetes is very popular because of all features that provide. So if you want to integrate it into your services, you should run your runner as a pod. A GitLab runner runs as a pod inside the Kubernetes cluster, usually in a specific namespace. The runner does not run on all work nodes. Kubernetes schedules the runner pod on the worker nodes. It's totally a pod. You can consume it as a simple pod in the Kubernetes. And when you push some code, the runners pull GitLab for jobs. GitLab never push jobs to the runner. Indeed, this is the runner that pull and consume it like a person go and ask, is there any changes? If yes, so it's run it. When a job is assigned, the runner communicates only with the Kubernetes API server. The Kubernetes scheduler decides which worker node will run the job. For each CI job, the runner creates a temporary pod on a worker node. The job runs inside that pod, test it, build it, deploy it, anything is that. After completion, the pod is automatically deleted. The runner never talks directly to the worker node or Kubernetes. And this is very good, give you and provide you isolation, scalability, clean execution environment. And now, let's look at this diagram and understand how GitLab works together with Kubernetes in real CI/CD step. I want you to follow the flow, not memorize the component. Everything starts from the developer. Step 1. What happened? Code push to GitLab. As you see in the I can't do it. Let's see it from here. Yeah. Source code. As you can see in the bottom of the diagram, we have the developer pushing code to GitLab. This push event is very important because in GitLab, a push is a trigger. The moment code is pushed, GitLab check, do we have a pipeline defined? And if yes, it creates a pipeline. GitLab create the job, not execute it. Now, something very important to understand. GitLab itself does not run jobs. GitLab is the brain, as I told you already, not the workers. So GitLab create the jobs based on the gitlab-ci.yml file. But it needs someone else to actually execute it. GitLab runner pulls GitLab. This is where GitLab runner come in the diagram. You see a separate cloud where GitLab runner is running. This runner periodically pull GitLab and ask, do you have any jobs for me? This is a pull model, not a push model. GitLab does not push jobs to runner. Runner pull jobs from GitLab. And also, runner uses Kubernetes executor. Now in this architecture, the runner is connected to Kubernetes. This means the runner is using the Kubernetes executor. So when the runner receives a job, it does not run it directly. Instead, it asks Kubernetes control plane and anything, please schedule a pod for this job. Kubernetes schedules pod. Kubernetes now does what it does best. The control plane design on which worker node should this job run. Then Kubernetes create a pod on worker node. Inside that pod, the job is executed. This is very powerful because every job run in isolation pod, and after the job finished, the pod is destroyed. In build job, image creation happen. Look at the build job path in the right side here. Docker built a container image. The image is tagged properly. After that, the image is pushed to the container registry. This registry can be GitLab container or any external. And after that, the deploy happen. Come to the deploy job. For development, the runner again asks Kubernetes to schedule a pod. Inside that pod, we usually run tools like kubectl, Helm, and more. This deploy job talk to the Kubernetes API server and tell it update this deployment, use this new image, rollout and new version, and finally Kubernetes run the application. Once Kubernetes receive the deployment command, it pull the image from the registry and start new pods. All pods are gradually removed, new pod come up, traffic shift safely. This is how we achieve zero downtime deployment. And yeah, you have everything you want here. Also, I can show you a demo, a small demo. If you can see here, I have a project, a simple project that have 3 jobs: test, build, and deploy. We're not going to about details of these jobs. In another video, we're going to talk about syntaxes and we'll start to running GitLab and connect it to the Kubernetes. But in this video, we are not going to do that. Just this is in this Go project. In Go test, we run the test. In build stage, we log into the Docker IO and push our image to that container registry, and finally in deploy phase we pull our image and deploy it on Kubernetes. So a bonus part is what I will explain for you as a bonus. Up to now we talk about CI/CD, how code moves from a developer's laptop to production automatically. But there is a very important question we haven't answered yet. Who is responsible for keeping production in the correct state? So the problem CI/CD alone doesn't solve. In classic CI/CD, the pipeline actively deploy to server or Kubernetes. This pipeline say deploy the version now, but over time problem appears. Someone run a manual kubectl apply, someone hotfixes production, someone change a config directly in the cluster, and slowly production drift away from what is already be. So what is the solution? At that point, Git no longer reflects reality, and that's dangerous. GitHubs come to help. If I search here for, and this is my pipelines. Some of them fail because of the problem that I have, but as you can see, there is successful pipeline, and this is where deploy it and change the server code. So if you search GitHubs. You can find a lot of good things. GitHubs change the direction of control. GitHubs flip the model completely. Instead of saying CI/CD push changes to production, GitHub say production pull its desired state from Git. This is huge mindset change. Git as the single source of truth. In GitHubs, Git is not just for source code. Git becomes the single source of truth for Kubernetes manifest, Helm value, environment configuration, infrastructure state. If it's not in Git, it should not exist in production. Desired state versus actual state. GitHubs is built on a very simple idea. There is a desired state defined in Git and actual state what's running in Kubernetes. A GitHub's system continuously compares these two. If production drifts away from Git, the system notices and corrects it automatically. And in this way, we can always have a trusted production state and no one change it. GitHubs has a huge world. I don't want to jump on it now, but I give you the idea. You can search about it, and in next video we can talk about it more. So thank you for listening and watching this video. I hope you enjoy it. You can try to run GitLab on by your own until I publish the next video to show you how to run it, what is the needed, and anything you need. Thank you for watching. Subscribe to the channel. Have a great time. Goodbye.